What are the things we discussed yesterday? Yes. Aman Kumar. Yes, Aman. Aryan.
Yes, ma'am.
So what we discussed yesterday?
Ma'am, I think further into time complexity, I'm not sure, I don't remember properly, ma'am.
Yeah. So we discussed about the time complexity, and we discussed about some few more examples by taking some of the codes and for various types of for loops. So we have discussed that, and we have also discussed about the definitions of the big O notations, right? So
Yes, ma'am.
yeah, so in this class we'll continue with that, and I'll so for the basic data structures, for the linear data structures, what we have discussed earlier till now, so far what we have discussed for array implementation, linked list implementation. So how to what are the time complexity of creating and inserting the elements in the array or linked list, and how to delete, how to traverse, what are the time complexities of each of the cases or each of the algorithms that we will discuss in this class. And I'll give you few of the examples, and you can follow along with for rest of the other data structures, like you can go for the stack and the queues also. Okay, so let me just share my screen first.
Excuse me, ma'am.
Yeah.
I was having a general doubt.
Yes.
Ma'am, those quiz that we attend at the end of the class, does they contain the weightage in our whole 100 marks?
Yes, yes, it will be coming under the quiz actually. So for quiz, you have I think 10 marks, right? Quizzes and assignments, the class assignments. Then for you have two digital assignments also,
So there
right?
will be
So
digital Yes, ma'am.
there will be digital assignment, two digital assignments. So for cat 1, cat 2, and this quiz is coming for another 10 marks. Okay, so 30. Then you have two cats, right? That is also that for cat 1, cat 2, 30 and 30, I think you are taking.
Yes,
Okay.
ma'am. They are
Yeah,
30.
15 to 2. Then PAT is 40. Yeah, that's it. Yes.
Okay, ma'am. Thank you.
Okay. So is my screen visible? I have shared it, right?
Yes,
Yeah.
ma'am.
Yes, ma'am.
Oh, okay, okay. So to start with, so we have seen yesterday what would be the time complexity for different kinds of for loops, okay, and how do we estimate that. So based on that, we were finding out the big O notation, okay. In worst case, what would happen, right? So here I'm explaining about how, like, when we have started our basic data structure, so we have started with the array implementation, and we have seen the logic behind how, what are the, what would be the logic for like declaring the array, instantiating the array, initializing the array, if we are talking about 1D array. So to start with, so when you are declaring the array, so what you are doing is, you are not so you are creating just a variable, you are not creating any memory space, so it will be of order of 1. So when you allocate the memory, that is the instantiation part, so in that case also it will be of order of 1, right? When you start initializing, means if you want to insert the elements for all the, like, all the indexes, okay. So in that, let's suppose we are taking n elements, means if you initialize each and every element. So that it max. At worst case, it will take order of n. Okay, starting from, like you can say, you can take a for loop and loop it through and just start adding the values. So it will be of order of 1. So when you are taking, when you are doing the creation of the array in initialization, it is of the order of 1. Okay, creating empty array is just order of 1. Initializing it with values is order of n. Okay, now when you are inserting a value in a position in any index, so in that case what would happen? So we have seen this is the logic. So what we are checking? We are checking if the array location is occupied or not. Okay, if it is occupied, then it will return the error, or else it will allocate the value which you want to be which you want to insert in the specific index. So for each and every case here, what we are doing is we are just checking a particular index, so it will be of order of 1, right? Else condition order of 1, and you are just inserting the value. You are not looping, doing any kind of for loop, or you are only doing for only one particular specific index, so that would be of order of 1 again. Then traversing the array, here what we are doing is we are looping from 0 to the array length. That's why it is of order of n. Okay, and this print function will take only order of 1. So here the time complexity will be order of n, and space complexity will be order of 1. So when you create one array of any specific n elements, for creating the memory location, that space complexity would be of order of n. I have forgotten to mention. But for rest of the things, for traversing and all, you have already created, so we are not bothered about further any further different spaces. We are just talking about the same spaces. Okay, so here for just for traversing this one, so the order for traversing, it will be order of n, and the space complexity would be order of 1. Next is, if you access a particular cell of the array. Okay, so here also what you are doing is you are checking if cell number is greater than size of array, it will throw an error, or else you are just returning the index of the array. Okay, the value of the array for this particular index. So that this all the functions would be order of 1, because you are just taking one index position and you are checking whether it is there in the array or not, right? Next case is searching a given value in the one-dimensional array. So given value, you have gotten a particular value, and in your array there are few values already existing. So what you are doing is you are checking, by taking this value, you are checking all the indexes starting from 0. You are checking all the indexes one by one. That means what you are again taking the loop. So this will be of order of n. Okay, so if you are checking if array equals to the value which you want to search, then it will give you the index, otherwise it will return the error. So this one is also order of n. Next is deleting a given value from the array. So for deletion also, so you know which location you want to delete, which index you want to delete, right? So what you're doing is you're checking if it is occupied, means you are taking array location equal to integer dot min value. So some very the most in integer, it is the least value available that you can assign. So that means what you are taking some garbage value, you are replacing it. So it is almost like you are deleting the value which you have already inserted. Okay, so or else you can say it is already blank. If it is blank, means it will give you blanks. For this one, since we know which index we need to access, so here you just this is of the order of 1. All the operations are order of 1. Similarly, space complexity also order of 1. So altogether, if you see, when you are creating an empty array, it is of order of 1. When you do the initialization, that would become order of n. Okay, by putting some values. If you are putting n values, then it will access each and every loop and keep on inserting. That's why it will become order of n. And space complexity also is order of n. Then inserting a value in an array, like accessing the array index and just inserting there, that are order of 1. Traversing is order of n, time complexity. Accessing given cell is order of 1. Searching a given value is order of n. Okay, because given a value, you are looping through the indexes and checking which where exactly this the assigned value is available. Okay, whether it is available or not. Okay. Similarly, deleting is just take the index and delete it. So order of one. Is this clear so far?
Yes, ma'am.
So we'll see the two-dimensional array also. So for two-dimensional array also. So when you are declaring and instantiating, it is order of one, and for initialization, you are inserting some value. So since it is taking the row and column index, so two for loops. So that's why it is order of m cross n, right? So m being the row, n being the column. Now similarly for inserting, it will be order of one only, taking the same rules, because you are just inserting the value in a particular index, okay, in particular row, in particular column, that is already known. So you just access that index and just keep insert, like you can insert in that specific index, so it will be of order of one. Next one is traversing is again, so we are traversing from like row wise and column wise. That's why this one is order of n, this one is order of n. So it will be order of m cross n. Okay. Next is sorry, accessing a given cell value. So for accessing a particular cell value given this row and column index, it will be of order of one. And searching a particular value in the array, so it will be of looping through two loops, for loops, order of m cross n. Rest of the things are just order of one operation. Okay, so time complexity is order of n, m cross n. Similarly, deleting also is order of one, because what you are taking, you are accessing the index array row and column position and just assigning with integer dot mean value. Okay, so this is all about the operations for two-dimensional array, right? So creating array is order of one, space complexity is order of m cross n, and this inserting is order of one, traversing is order of m cross n, accessing is order of one, searching is m cross n, deleting is order of one. Okay, and for rest of the operations, space complexity is order of one. Okay, so it is as similar to the one-dimensional array. Only one column index we are adding apart from the row index. Okay. Is this clear?
Yes, ma'am.
Okay. Now we'll see the linked list. Okay. So to start with, I'll tell you about the single linked list. So single linked list, when you are creating a first one node in the single linked list. So what is the logic is, we are creating head pointer, we are creating tail pointer. So order of one, creating a blank node, we are assigning node dot value, order of one, node dot next, order of one, head equal to node and tail equal to node. So all of this is creating one node is of. Is my screen visible?
Yes, ma'am, it's visible, ma'am. Yes,
Visible,
ma'am.
ma'am.
Who is waiting in the lobby to see who is waiting? Just give me one moment. No, I have added all of you. It's others. Okay. Okay. So yeah. So insertion of an element in the single linked list is, so there are three ways to insert: inserting in starting, inserting in the end, and in any position in between, right? So to start with, what we'll see, create a blank node of which we want to insert. We can put it node dot value. Okay, so these things we have already we know from the previous one, and we are checking if the linked list is existing by taking the head pointer whether it's null or not. Then what we will see, if not, it will throw an error. Next is the three conditions we are checking: the else and else condition. So in this case, so inserting in the first position is of the order of one, Then node, so how do you insert? So node dot next you assign it, head equal to node you assign it. Okay, so this is the insertion operation at the starting. Now inserting at the last operation. So if you have the tail pointer already, then you can just access the through the tail pointer to the last node, and from there you can put this node dot next equal to node, null, last dot next equal to node, and last equal to node. So you are as you have created one node at the end of the linked list, so that means what you are, so what you are doing is, so earlier this was null, so now you assign the new node's value here, okay, and put node dot next equal to null, and here you insert some values, and tail pointer you can point it to the new node instead of this the earlier existing last node, right? So if you have the tail pointer, if you don't have the tail pointer and you are accessing from the head pointer, taking head dot next kind of thing, so there what you have to do is you have to traverse all the way till the last one, last the last node, then you can add, do the insertion. So that in that case it would be, in worst case it would be of order of n. Okay, so here for the last question, these are the cases. And if you want to insert in any position in between, so then also what you do, you have to from 0 you have to traverse till the where you want to insert the node. So the last the location -1, right? If you want to add at the third position, so you have to reach till second position. Okay, so in worst case that also will be taking order of n time. Okay, then you can do the assignments, the node dot next equal to temp, node dot next, temp node dot next equal to node. So you just keep this node, new node between the already existing two consecutive nodes. Okay, so these are the three cases. Is it clear?
Yes, ma'am.
Okay. Now traversal. So for traversal, what you are doing is you are looping from head to tail, and you are printing the current node. So head to tail order of n. So this one is order of 1. You are checking if it is null, order of 1. So time complexity is order of n. Sorry.
Ma'am, I have a doubt.
Yeah.
Ma'am, why always we are talking about time complexity and not about space complexity?
No, so space complexity also we are talking about. For space complexity for linked list, so what you are doing is you create a node that it is order of 1 only. Okay.
Yes.
Yeah. So here there are few changes happening to the code. So when you create a node, it is just order of 1 for space complexity, right?
Yes, ma'am. Yes.
Yeah, that's why I like it is there. I have explained in the first slide maybe, so I'm just ignoring here because there is no change, right?
Okay, okay. I got
Yeah.
it.
Yeah. So so for searching the node in the single linked list, so what we are doing, we are again looping through start to tail, and you are saying checking the node value, and you are checking if it is there or not. So for here for this one it will be order of n. The rest of the things you are just doing the, like if it is equal, then the order of n. So printing order of 1, printing order of 1, returning order of 1. Okay, so if it doesn't exist also, you are just returning the value order of 1. So this will be order of n. Okay, now similarly, for deletion of the node, again we'll go with the same way. So deleting from different positions at the start, at the end, and in any position in between. So in this case also, what will happen is, what we are doing is, you are checking if it is existing order of 1, return. If it doesn't exist, it will return the error. Then the three conditions. So location equal to 0, so it will be order of 1. These are the assignments you do. That is simply order of 1. Next is if it is the last node. So here what we are doing is, we are this is the last node. Okay, right? So what will happen is, so here what you are doing, you are assigning, you are reaching till last but one node, and you do the deletion, right? here. So because you will assign the tail pointer here, right? So here what we are checking is if it is if the location is last, that means what? So if it is a single node, that is order of 1. If it is having more than one node, so you are reaching till last but one, so second last node you are going. You are not going to last node in this case. So again, this case it will be order of n because you are traversing from here to the last second last node. Okay, then the assignment will take order of one operation. Else condition, any position in between. So what you're doing, so you're looping from start to the position, the last the position in which you want to insert the previous position, to that you are traversing till the previous position of the position in which you want to insert. Okay, so location minus one, which location you want to insert. So that also will be, in worst case it will be order of n. Then the assignment is you do the required assignment, that also will be order of 1. So time complexity also is order of n here. Okay, is this clear for deletion?
Yes, ma'am.
Yeah, so I have just explained the basics, how to do with the array and how to do with the single linked list. For rest of the things, you can like taking the same concepts, you try it out on your own for all the things which we have done in the class, for circular linked list, for then for the doubly linked list, circular doubly linked list, then coming to the stack operation, the operations, various operations of the stack, all the logic, whatever logic is there, you try it out on your own based on this. These are the based on the logics which we have explained so far till now. Okay, the like yesterday we have seen how to do with the log n, how to do find out the root n, then n square, right? So those operations we have seen it. So we can, you can try it out on your own and let me know if you have, you find some issues in between. So algorithms you have, only thing is you need to find out what is the order of the entire algorithm. Okay, the time complexity of the entire algorithm. Is it okay?
Yes.
Yeah, so try it out and let me know. We have time, and if like I think your exam is on coming on Wednesday, right? When is your exam?
Yes, ma'am.
Wednesday,
Yes,
ma'am.
Wednesday. So we have time. You go through it or try it out. Rest of the things, and also the exam would be not straightforward. It would be of some scenario-based one. So try solving from the web whatever is possible. But it will be of the concepts which we have covered. It won't be as straightforward what we discuss in the algorithms. Those are the basic logics, but it will be of some kind of scenario based cases. Okay, I'll give you some sample questions anyway, but you try all the possible. You can go for the lead codes. There are many things you can find out, and also you can try some other questions from the web also. Okay, come prepared with it. All the best. Let me know if you find any issue. We'll have one more discussion class, or we can, you can say, you can approach me one on one also. Okay.
Okay.
Yes,
Okay.
ma'am.
Excuse me, ma'am.
Yes. Yeah.
Ma'am, can you upload sample paper or some sample questions so that we know exactly what will be the
Yes.
type of questions in the paper?
Yes. Yes. So by end of today, I'll upload the sample questions also, and
Yes, ma'am.
you can have an idea about it. But try to solve as much as possible. Okay.
Yes,
From,
ma'am.
yeah, from the books which I have shared, and I will share one or two more books also. It will be of same similar kind only, but you try to solve many other like algorithms from the web only to understand which concept they are taking, which logic they are taking, and for one particular problem there will be many ways to solve, which one is giving least time complexity. You practice a lot. Okay.
Yes, ma'am.
Okay then. So if anything
And
is there, let me
ma'am,
know.
one more.
Yeah.
Ma'am,
Yes,
one more thing, ma'am. The course for the CAT one is till today.
till today. So we have first two modules, right? So till today.
Okay, ma'am. Thank you, ma'am.
Yeah. Okay.
Ma'am, are
Ma'am,
all the PPTs uploaded, ma'am?
Sorry?
All the PPTs have been uploaded, right, ma'am?
No, this class PPT I will upload. So it is under class materials. You just check in Teams class materials. All the PPTs I have uploaded.
Okay, ma'am. Thank you.
Okay. Yeah. Anything
ma'am,
else? Yes.
yeah, ma'am, you said about mark distribution, right, ma'am? For DA1, DA2, and quiz. Again, you will conduct quiz or already kept quizzes will take, ma'am.
So quiz this is for final evaluation. We are done only till CAT one. There will be many quizzes, many
Okay,
classes.
ma'am.
Yeah.
Yes, ma'am. For DA3, it should be quiz and it will be separate. You will inform earlier, right, ma'am?
For the digital assignment, I will again still we are not yet sure in which platform to take, whether to take in any online platform or like assign with you some specific problems. But it will
Okay,
be
ma'am.
coming very soon. Probably in
Okay,
this
ma'am.
week, I can upload. I'll update in WhatsApp group once I
Okay.
am getting confirmation from the coordinator. Okay.
Yes, ma'am. Ma'am, yesterday's quiz and all for our practice purpose, right, ma'am?
No. It is for see from starting day till your the last day of theory class. All the class quizzes and class assignments. This is not talking about digital assignment. The class assignments. Everything
Okay.
I'm taking it together, and then
Okay.
I'll be doing the average
Okay.
of it. Okay.
Oh, thank you, ma'am. Okay, ma'am.
Yeah. Okay. Anything else?